Okay, we are getting pretty close to the end of the semester. This is our last week of classes, of course. We'll have the final exam next week. Um, but your last homework assignment is due on Wednesday before class. And the material that we're going to be covering today will be included in the final exam, but you're not going to have any kind of assignment related to this or the taxes stuff that we're going to do on Wednesday and Friday. So your only chance to practice those will be in class. I'm continuing to work through, will you close the door, please? Thanks. I'm continuing to work through the projects, and so far those look pretty good, but I'm posting the grades as soon as I go through each one of them. I've got about half of them done. I hope to do the other half early this week. Any questions before we talk about Monte Carlo simulations? Okay. What I hope you'll remember from last class was the idea that there are a lot of things that can vary. And just to quickly look through some of the figures, interest rates can be really variable over time, and it's hard to predict in the future what interest rates might be. Commodity prices, labor costs, those things can vary a lot, and because the inputs vary, your outputs can vary as well, meaning specifically like how profitable a particular project might be. And so one approach we're going to use today is called a Monte Carlo simulation, and here's a picture of Monte Carlo. It's a city on the Mediterranean that's kind of famous for its casinos. And so this kind of simulation is where we're going to randomly vary certain inputs to our analysis, variables, and we're going to see what's the resulting profitability. So just think that there's a distribution of likely values for any one of the inputs that we're most interested in. And here's a normal distribution, and not every variable follows a normal distribution, but just for simplicity as a first taste of how we could look at probabilistic distributions, just assume that maybe if we know the average to expect for anything like costs or interest rates or useful life, even if we know how long those typically, a piece of equipment usually lasts, there are going to be a handful of examples that have a much shorter useful life. Some of the examples have a much longer useful life, and so there's this distribution of likelihood. And what we'll do today in our in-class exercise is we're going to play around with 4 variables and see how the overall profitability of a project turns out. If we don't necessarily know how much the equipment cost is going to be, we don't know how long the equipment will last in terms of its useful life, the revenue it's going to generate, the interest rates, but we will start off with an assumed average and then some characterization of how wide the normal distribution is. And so standard deviation is related to how far away from the average you have to get in order to capture a certain percentage of the values. And so 68% of the values are within one standard deviation. And so what we'll do is we'll say, if we have an idea of what the average cost of the equipment is likely to be sometime in the future, and then we also know or estimate how wide the standard deviation is in terms of dollars, or if we're talking about useful life, the units of the standard deviation, and the average would be years. We're just going to try and characterize the bounds of the likely values and then randomly vary each one of the variables and put together, in our case, 10,000 combinations and look at if we have 10,000 simulations of randomly assigning values within a range of probabilities, then in the end result, is the project going to be profitable, and if so, by how much? And so the overall profitability will be combining how long the equipment is going to last, combining how much it cost, how much our revenues are expected to be. And each line or each row in our spreadsheet is going to be 4 variables, each randomly generated, and then within a narrowly prescribed range of possibilities where it's starting with the average and then the random generation is going to fit the normal distribution that we're characterizing. So that's just to set the stage. Most of what we're going to do today is in the spreadsheet, but to just get a taste for where things should go if we were going to calculate this without any variability, let's do this first part just manually using the given factor table. We want to know the present value of a business opportunity where we can buy some equipment for $50,000 and we know it's going to last for 6 years. So knowing that, and that there's going to be a net revenue of $11,500 each year, then without any, like if we have perfect certainty, what would be the present value of this business opportunity? If we don't have any uncertainty whatsoever of the cost of the equipment, how long it'll last, the revenue, or the interest rate. With everything fixed, just to set the stage, let's do this part one. Okay, I've got the solution here on the whiteboard, and so the first cost is already at the present, that $50,000 purchase price. And what we need to discount is the annual series of $11,500 in net revenue each year. So that's the revenue minus those years' operating costs. So we want to find what's the present value of 6 payments of $11,500. So find P given A where the interest rate is 5.1%, N equals 6. And so you can see that I use the equation method and the factor, the P/A factor is 5.0595. And we need to multiply that by the 11,500. And so the present value of the revenue is $58,184, and then if we subtract out the $50,000 purchase price, that means that the sum of the present values, taking into account the cost and also the revenues, is $8,184.25. Okay, so that would be our expected present value of the business opportunity if it's exactly $50,000 that the equipment is going to cost, and it lasts for 6 years, and it has this annual net revenue of $11,500. But what we know, the reality is more complicated than that. That there can be a lot of uncertainty in the world, and so if we just wanted to test out what's likely to happen under a range of more realistic conditions, on the back side of the paper you can see the scenario for part 2. Okay, so what we're going to do together is open up Excel, and we're going to have a variety of cost possibilities. What we know about the equipment is that it's likely to cost, on average, $50,000, but the one standard deviation in cost is plus or minus $2,000 of that amount. I have it listed here as 67%, but it's actually 68%. But what I meant is we expect that most of the time that we run this simulation, the cost would be between $48,000 and $52,000. Some of them will still be more and less than that, but very few. It will follow the normal distribution. The function we're going to use in Excel, it's going to assign the average cost to be $50,000, and most of the rows, we're going to have 10,000 rows, most of them will be in this range of plus or minus 2,000, but some of them will be more than that. And it'll use the standard deviation to assign that, that distribution. The same thing is going to hold true for how long the equipment lasts. We know that the equipment has a 1-year warranty, so that's how long we could guarantee it's in service. But we know that on average this equipment lasts for a year, and it seems like the standard deviation is plus or minus a year. So we're going to do the same thing in having the number of years. So n will be varying from 6 as a starting point. And we're going to have a two-step thing that we'll need to do there, because we're going to have it randomly generate the useful life, but then we're also going to have to turn it into an integer, because the way that the probability generator will work is it's going to come up with n in terms of a decimal. And so there's a two-step function we'll use for that. Revenue is going to average 11,500, which is the value that we used on the whiteboard, but then it's also going to vary within this range of 1250 plus or minus for the majority of the simulations, but then some of them will be less or more than even that. And then of course you can see the interest rates are also going to vary. 5.1% is the average, and we're hoping or expecting that the majority of those values will be plus or minus 0.9%. So the things we're going to try and figure out from these 10,000 simulations is, what's the average present value? If we have this as our setup, what's the average expected present value of the range of outcomes? So some of the outcomes, just to skip ahead and reveal the answer, some of the time we're actually going to lose money. It's not always going to be profitable, depending on, like if we have one of the rows where the number of years is low, the cost is high, and the revenue is low, but the interest rates are high. You know, there's a combination of factors that could be really unfavorable if you're just unlucky. Or you could be really lucky, where the cost is less than expected, and for some reason the revenue happens to be higher than expected, the useful life is longer, and the interest rates are lower. So there's going to be all different combinations within these 10,000 cases, and some of them are going to be profitable, some of them are going to be unprofitable. And so what we want to know in part B is, how often is there going to be a loss where we actually are losing money with this business opportunity, representing, you know, we want to know how bad is the risk of not being profitable. And then we want to know, for those simulations that are profitable, what's the average profit amount? Same thing for losses. For those simulations that are losses, what's the average loss? And then this last one is, we're just going to try and say that what is the amount where only 10% of the outcomes are greater than that amount. So it's, maybe we could think of it as the best case scenario. It's not the absolute best case scenario, but if we think that most of the time we're 90% lucky, or we seem to defy the odds 90% of the time, we're just trying to get an idea of, like, what's the maximum bound of values that we could expect if we want have this 90-10 sort of split. Okay, so with that set up, let's just start up Excel. And I don't have a pre-formulated template for you to follow, but I'm going to demonstrate it on the screen and ask you to follow along. And so up here at the top, we'll just call this in-class exercise number 39, Monte Carlo. Okay, so the average cost that we're given in the problem statement is 50,000. And that's an outflow, so I'm going to have minus 50,000 for the average cost. And actually, let me just call this average, because here I'll call it the cost, and then next to that I'm going to have revenue. And you'll remember that the average revenue, same as what we just did on the whiteboard, is 11,500. And then the average useful life, so the average n value, is 6. All right, so then on this next row is where we're going to specify the standard deviation. So what we had from the problem statement is that the cost is going to vary plus or minus 2,000. So here we just put in the absolute value of the standard deviation. So it's 2,000 for the cost. The revenue The problem statement said we think that the revenue is going to be within 1,250. And then the n value, the standard deviation there is 1. Okay. So just starting with this, let's get a feel for how to use the functions that we need in this. We're going to have a simulation number. And then for that simulation, we're going to have the cost of that simulation, the revenue, and this is per year. Just to make that explicit, I'll actually let me wrap it. And then n, which is the number of years that the equipment lasts. Okay, so just to start off, 1, 2, 3, 4, I'm going to have to drag that down through 10,000. But so we want to use this function that's going to use a random number generator and follow a normal distribution. And the embedded function for that is equals NORM INV. So the returns the inverse of the normal cumulative distribution for the specified mean and standard deviation. Okay, so inside this, we're going to have to generate probability. So we're going to just have random probability, close, open and close parentheses. So we're just telling it, use a randomly generated probability. And now you can see it's asking for the mean. So it wants to know what's the average value for the cost. And so click up here for the cost and anchor that reference, because as we drag down, we always want it to look at this average that I've assigned. And then for the standard deviation, click on the $2,000 standard deviation and then anchor that again as well with the dollar signs. Okay. So normal distribution using a random number generator. And so you can see this first value is it's saying 54,914 in cost. And let me format this as money just to make it explicit here what we're talking about. Actually, I'll do this whole row as money. You're going to get different values, right? You're not going to get the same thing as this. Anybody get the exact same thing?
You not set a random range?
I don't think so. No. I don't think we do.
Question.
Mm-hmm.
Is the value supposed to change every time you modify anything else in the table?
Yeah, if you press F9 or if you save, there's a variety of things you can do and it'll automatically update a cell that is calling on this random generator. So if you pressed F9 1,000 times, your average should be 50,000. But you'll see some of them are much lower and some of them are much higher. So if you drag this down through several of them, it should be focused on 50,000. The interesting thing is that even when we have 10,000 rows, it's still not going to be exactly 10,000. Excuse me, when we have 10,000 rows, the average cost still won't be exactly 50,000, but it'll be close enough that this is going to be a meaningful simulation. Okay, so let's do the same thing with revenue. It's going to be the same function. So if you missed it the first time around, here's a chance to see it again. Equals norm INV parentheses rand, and then our mean will be this average, and the standard deviation will be, for this one, the 1,250. Okay? So you can drag that down, and anytime you make a calculation, it'll update it. Okay, we'll do the same thing. Now I'm going to rename this n. It's going to be my decimal version of the n's. And then next to that, I'm going to have the n integer. I don't think that's how you spell integer. Let me just do it this way. Int. All right. So for decimal, we're going to do same thing. Norm in rand. The mean will be here. The standard deviation will be there. And now we've got some random assignment for how long the equipment lasts. And here you can see a huge one. Here we've got one that lasts 8.3 years. And so that should be very rare based on the average value and the standard deviation that we've set. And then this is really low, 4.3. So now we want to find out, we want it to automatically round to the nearest integer for that. And so we're going to use a function equals round and click on the thing that we want to round, and then the number of digits are going to be 0. So that'll turn it from some decimal value into an integer, which is what we're going to use when we're calculating present values. Okay. So any questions so far? Is there anything that I need to circle back to? All right. Well, if not, let's specify up here our interest rates that are going to vary. So here I'm going to have the rate. Well, let me put it in the same row. The rate. And our center point is 0.051. That's the average. And then the standard deviation 0.009. So 0.9% is expressed as a decimal, 0.009. Now, let me actually move it over, because here I'm going to have the interest rate. And so we're going to do, again, the norm INV with the probability being random, and then the mean being this given mean value, the standard deviation being that. And so now we've got, look at all the things that are varying: the cost, the revenue, how long it lasts, and the interest rate. And now that we have those things defined, what we can calculate is the present value for the project. So here we're going to have the PV, the present value of the project. And so remember that the present value of the project, the way we calculate it on the whiteboard, is it's the cost plus the present value of the revenue. So we're going to do the cost plus PV of, and now we're going to use this interest rate. It's asking here for the PV. It wants to know the interest rate, the number of years. So I'm going to use the integer n value. And then for payment, I'm going to put in this revenue per year. It's a recurring amount. It's a uniform series, so it goes in the payment field. So the minus of the amount. Remember that the built-in functions would change the sign, and so we have to put in the minus of the amount to keep that as a positive value. Okay, so what we should see if we drag that down is that some of them are going to be profitable, some of them maybe not. If you calculate it multiple times, you'll see some that are negative, some that are positive. Okay, so that's the present value. And so let's split that up, because this is going to include some which are profitable and some which are a loss. And so let's have a column where if it's profitable, it will tell us the amount, and another one where if it's a loss, it will tell us the amount. Okay, so now I need to do an if statement. And so we'll do equals if this is greater than 0, then make it the amount. Otherwise, if it's false, let's just have it say false. And I think having the parentheses is the way to go. I'm sorry, the quotes if I want it to report text. Okay, so if it's greater than 0, it'll say the amount. Otherwise, it'll say false. Okay, so if I drag this down, here, it's triggering false for the one that's negative, but it's just reporting the amounts for the others. So it's doing what we would want. That's good. For the loss, let's do another if statement, equals if this is less than 0, then report the amount. Otherwise, report false. Now, you'll notice that $0 is excluded. So if we happen to have a simulation that is exactly $0, it's not going to be counted. But that's unlikely. So the loss should tell us the amount when it's a negative. So it looks like it's, oh, I spelled false wrong. There we go. No, that's right. It just looks weird. F-A-L-S-E, false. Okay. Sometimes, you know, you get snowblind when you're up in front of the screen. All right. So does everybody have this set up correctly? Because what we need to do now is we need to extend this down through 10,000 rows. So I think what we can do is just drag all of them down. And if you look over to the left side of the screen, you can see it counting up, and this will be tedious. 1,000, 2,000, 3,000. We'll just go to 10,000. Hopefully not overshooting. Okay. I'm not sure which row I started on. Need a few more. Luckily, I've got a counter going, so 5 more. Okay, so there's 10,000 simulations. Now, what we're going to do is we're going to look at some of the averages and like how often does it succeed, how often does it fail. So remember that anytime we press F9, it's going to update these values. So it would be interesting. Let me just add another row here. Let's see, what is the average, like actual average? So if we calculate the average cost, I'm going to do Shift, Control, and then the down arrow button. And that'll take me to the bottom of the list without having to scroll. So we wanted the average to be negative 50,000, and it does its best, but you know, there's random variation. And so the actual average out of 10,000 simulations is 50,029 and 87. So let me do the same thing here on revenue. So I'm going to do equals average, and then have the first cell in the average down on simulation 1, then Shift, Control, and the down arrow will take you to the bottom of the list, and then you can just press Enter. So here you can see the actual average. It's close to 11,500, but it's not exactly 11,500 because each one of these values varies randomly without knowing anything about the other values. So the computer isn't like adjusting each subsequent pick of the value in order to force the averages. It is truly random. Okay, so I wonder what our average number of years is. So That's pretty close, 6.006, where we're aiming for 6 years. I could just drag this sideways and know the average interest rate. Pretty close to 5.1%. Okay, so the first question, if we look at what it's asking, what's the average present value of this distribution of outcomes? And so we want to know what's the average of this. So I already have the average formula going. I can just drag that one more column to the side. And just to make the point that this is money, let me format this as currency. So for this simulation, it's 8,100, but if I pressed F9, and it's going to update it again. It's not any one particular answer. There's a lot of variability. We'd probably need to have 100,000 simulations for that average to change less each time we pressed F9. Because we're varying 4 different variables. The more variables that you're changing, probably the more simulations you should have. We're sticking with 10,000 just so that we didn't have to drag it down for too long. But you could fill in the blank here on your handout with whatever value you got for this average present value. And so what this represents is, out of 10,000 simulations, the average present value is positive. So that means, on balance, you're more likely to make money than you are to lose money. And you could already see that in this profit versus loss column. There, in the profit column, there are fewer falses. There are fewer times that it's negative than times that it's positive. And in fact, let's set up a account where we have the number with a loss. So let me move this to the side. Let's count up how many of these are losses. So I think there's a function called countIf. CountIf. Okay, so count it if, okay, the range is going to be from here down to the bottom, and then back in here to the criteria, if it says false. I think this will count the number of times. Oh no, I must not have done it right. A loss is if it's actually a value less than, no, so we don't want to count the falses. We want to count if it is less than 0. I have to remind myself here.
Can you do just a regular if and then have 2 counts, the profit loss, and then compare them with the operand in between?
Yeah, I want to teach you guys this count if. So let me remind myself how I did it before. I'm going to pull open the solution that I've got here. When I only do these once a year, it doesn't stay fresh in my mind. Okay. Oh, okay. It needs quotations. All right. So count if. So we have the range, and then if it is less than 0 in the parentheses. Quotes. Sorry, not parentheses. Okay, so there's 10,000 simulations, and what we found is that 2,300 of them have a loss because that's where the value is less than 0. So, number of total simulations is 10,000. So as a percentage, it is going to simply be the number with a loss divided by the total number. So let me express this as a percentage. 23.9% of the time, you're losing money. So, you know, this is then information that you could take back to the decision makers in a company and say, you know, how comfortable are you with losing money? You know, the likely upside versus the likely downside. 23% of the time you're going to be losing money. What about the average when it's profitable? Let's do the average. Since we're just calculating averages on this, I think we can drag it to the side and it will ignore the times where it says loss, I think. And so when you have a profitable outcome, the average is around 12,000. And when you have a negative outcome, the average is around minus 6,000. Okay, so this is a really powerful set of ideas. We've done it for a scenario where there's 4 variables, but I mean, in theory, you can use it to investigate any number of variables as long as you've got enough computational horsepower to just keep running lots of simulations. And so people use this sort of technique to estimate, for example, the probability of a successful lottery outcome. Like if you have Powerball and you know how many numbers there are for each ball that comes out, you can find out the probability of getting 6 of them correct, 5 of them correct, and so on. Okay, so I think we've answered so far A through D. So A was asking the average present value, and we found that the average present value, that's this one. It's, for mine, it's saying right now 79.82. If I calculate it again, 8,000, 8,000, 77, 79. So in the range of $8,000 is the average present value. What percent of the time will there be a loss? That's not changing as much. You know how like every time I press F9, we're getting a slightly different present value? If you look at the percent of the times with a loss, it's varying less. About 24% of the time there's a loss. Okay, now this last question, part E, of the what is the amount where there's a 90% chance you'll make less than that amount? To do this one, we need to paste the actual values because everything keeps changing. So I need like a static set of the present values rather than something that's based on a formula. So for this, highlight the present values. Okay, so start on the first one, do Shift, Control, and the down arrow, and copy them. So Control C, and then off to the side, we're going to paste the values. And so Home, and we're going to paste just the values themselves. We don't want to paste the formula. We want to paste the numbers. Because once we do, then those numbers won't change every time we save or make some adjustment. So now I've got the actual values here, and even when I recalculate everything else, this set of values that I've pasted stays the same. So I'm going to call these pasted values. And the reason why I did that is I can sort it now. That enables me to sort the list. And so highlight this list. So Shift, Control, and the down arrow. And then I want to sort it from largest to smallest. So here, sort and filter, which is right on the Home ribbon. So sort and filter, largest to smallest. Okay, so I've got like the biggest value that I saw for that particular simulation was 53,503. So like what's the probability that I'd get that much money? 1 in 10,000 is the probability, because that was the top value, the top one value out of 10,000 possibilities. So this question in part E, what it's asking is, what is the amount where there's a 90% chance that you will make less than that amount? Or the other way to phrase it is, what's the amount where only 10% of the present values are greater than that? So if we go down the list and we find out, if we go down the list 1,000, so we find row 1,000, then that'll be the amount associated with a 10% 10% of the values are greater than that. So I'm just scrolling down here. You can see the count is on the left. If I find row, well, simulation 1,000, since it's sorted, 22,431. So what I would say is 10% of the values are greater than this. 90% of the values are less than this. And so we only have a 10% chance of making 22,400 or more. We've got a 90% chance of making 22,400 or less. So if your CEO was saying, we really need to make $22,400 on this business opportunity, you could say, well, there's a 90% chance that we won't, just based on the likely costs, the likely revenue, useful lives, and so on. So this allows you to kind of put some bounds around certain probabilities. So that's all the time we've got for today. Let me just revisit our announcements one last time. Homework 13 is due at the beginning of class on Wednesday, and then our final exam is the last day of finals next week on the 8th. I'll see you in class on Wednesday.